I have to admit, this is the first talk I've ever given. And of course, I went on the internet and looked up, what are you supposed to do when you give a talk? And there was someone who did a YouTube video and said, okay, here's the 3 ways to start a talk. They said the first thing you can do is you can start it and say, hello, I'm Joerg Beekmann. This talk is about hosting Fable elsewhere and so on. He says, well, no, don't do that. That's a terrible thing. Everyone will immediately pull out their phone because they just read about it and they've just been introduced, and you don't want to do that. The second thing you can do is you can tell a joke. So I thought, well, I'm not a comedian. That's like its own profession, so I don't think I'm going to be telling any jokes. He said the third thing you can do is tell a story that motivates, what this is all about and so on and so forth. And I couldn't really think of a story other than the story I just told you. So there we go. That's what it is. That's the story and the joke all in one. So, like I said, my background when I looked at tool and Fable, and it's just, it's a great tool. It just seems to work, and I immediately started thinking about where can you use this? Where else can you use this? There's a lot of activity using Fable to build web apps with Elmish and so on and so forth. But I think, can we use it on the server side? Can we use it in other cloud environments and so on and so forth? And that kind of brings us to this slide, my motivations about this. And there's going to be some opinions here, but really hosting Fable elsewhere means that what we're saying implicitly is that those languages that are there by default aren't the languages we want to use. Rather, we all want to use one language. We all want to try use F# wherever we happen to be. And I put the warning on there that, opinions ahead, because I thought maybe this would be a contentious thing, but I've been in 2 or 3 talks already so far where people seem to feel the same thing, and I guess that's natural. We're all here doing Fable on runtimes that are not Fable, so I suppose we've bought into that. So up to now, I kind of felt like this was like a shameful secret of mine, that I didn't want to use the best of breed solutions to these things. And if you go on Twitter and suggest that you might want to use one language in other places, you're going to get feedback telling you, well, no, you should use this language in that circumstance and this language in that circumstance, and so on and so forth. And I've had responses to myself. I couldn't find that one to this as well. But I don't actually think that's true. I think, first of all, the notion of the hammer and the nail is a terrible analogy for programming languages. Because if you think about it, a programming language is not just one tool. It's not, oh, you have got assignment. All you have is assignment. And and if you want to do a loop, you've got to find another tool to do looping. And that's not really what programming language is about. A programming language is, hopefully, a carefully selected, cohesive collection of tools, mental tools that you can use to solve problems. And if it's a well-designed language, you should be able to move it around and use it in multiple different contexts. Maybe not as perfectly in a given context as another language that's been custom made for that, but that kind of brings me to my pet peeve about this argument that we should use specific languages. I think there's way too much focus put on subtle differences and subtle benefits of using language X in a given context. And I really don't think those benefits are necessarily there. And I think there's really not enough focus put on getting mastery of a good toolkit and knowing where that tool can be applied and trying to apply that toolkit widely. And doing that, I think, helps each of us in ourselves, because when you go to a new problem with a tool that as long as the tool is suitable to that job, it doesn't need to be the absolute best one, you're probably going to be more powerful in that new context than if you're trying to start all over again with a different tool which maybe is specially designed for that context, but you're basically starting from scratch. You have no mastery of that tool. I think the other thing, and this is something that I feel even more strongly about in a way, and it comes from having spent maybe the last 20 years or so building an environment for payment processing that was written in Smalltalk. And over that time, we built ourselves a collection of tools that we could use that would solve each one of the individual problems. We did everything from hosting kind of a continuation-based web server in Smalltalk, to doing our DevOps in Smalltalk, to doing our scripting in Smalltalk. And with a small team, there were only about 4 or 5 of us, that meant that people could move around. If someone was not in, someone else could take over the DevOps thing. You didn't suddenly have to be a PowerShell expert in order to do the DevOps part. And similarly, if the problem was on the web server, the person who normally did the back-end things, it was the same language, different set of problems, but you had a fighting chance to fix those problems across the board. I think it also allows you to build kind of a sense of community within your team because you're all in this together using the same tools, and that builds over time. So yeah, so I guess that's that's basically the conclusion, that I think we should aim to try to all be using the same language and developing transferable expertise. And I think this is particularly true for small companies. I mean, if you're a very, very large organization and the DevOps team itself is 50 people, then sure, you're going to have these processes and so on and so forth. But even anywhere up to 10 people, I think you're better off trying to do everything with one tool if you can do it. So anyway, that's my motivation, and well, also I just wanted to avoid learning JavaScript, which you'll see I know very little about JavaScript. I forgot to start my timer here, but anyway. There we go. Okay, so that brings us to where could we use Fable where it's not being used right now. And it's actually, just having listened to some of the talks here, Fable is actually already being used in more places than I was aware of. And I had to update the slide a little bit. Well, not update the slide, but when I wrote the slide today, I could put in some of these other places where it's already being used that I didn't know about. But really, here's just a few of the possible options. We could, Azure runs JavaScript. We could run Fable there. I'm not sure if that would necessarily be a good idea, given that Azure can host .NET very easily. AWS Lambda, in particular the Edge version of AWS, might be an interesting target. That one there is what started me down this whole road, probably, I don't know, maybe 2 years ago. I don't know if you remember, Alfonso, way back in London, I kind of had this idea that we wanted to write stored procedures for CosmosDB because the JavaScript environment for writing stored procedures in CosmosDB is well, there's no what to say other than terrible. And I didn't actually get that done, but I think that's still something I really want to do because I think there's a lot of potential there, because not only does it help you write stored procedures in CosmosDB, but you could link APIs directly to those JavaScript stored procedures running in CosmosDB, and if you wanted to, cut out an entire function layer. You could have your application running within that database. So I think that's a very interesting way. Postgres, someone just told me today that you can write JavaScript stored procedures in Postgres. And again, you could run your application inside the database. These are, I know some people, I'm kind of a minimalist in terms of layers. So if I see a bunch of layers, I try to remove some. So this is from these things where, okay, people would say, well, why would you want to write your application inside the database? But I think for 90% of all the applications out there today, or maybe more, you don't need planet scale. Its simplicity is better. You can put other things in the front to do the security and so on. So that's kind of my notion. Of course, Node, that's actually already a demo out there for that. So that brings me to today's focus. I was going to kind of walk through how you could do one of these, what it actually took to get Fable running on Cloudflare Workers and how that worked out, and kind of what my experience was doing that. So who's aware of Cloudflare Workers and what they are and what their programming model is? Okay, yeah. You can see this is kind of the traditional way Cloud Lambdas and Cloud Functions work. There's some sort of, where you have your function app, a Docker container will be spun up for you, or maybe a VM, or some fairly heavyweight thing that is yours, and you have your functions on there. But if your function is, for example, just hello world, or something very simple, that's a heavy load for just that very straightforward thing that you want to do. What Cloudflare did is they said, okay, we've got all these points of presence all over the world, and we want to provide a web programming environment as well, and we want to use it to replace our normal replace the scripting language that can normally be used to modify requests when things go through Cloudflare. So normally you can do things like, check to see if it's a post, and if it's a post, immediately decline it at the edge layer, that kind of thing. Let's use JavaScript to do that. And how can we provide, and obviously those are very small functions. We can't provide a heavyweight thing. So how can we provide a lightweight execution environment? So what they said is, well, wait a minute. Chrome and V8 has this notion of these isolates that run inside Chrome. And this is where the service workers, if you start up a service worker in your browser or start up an iframe in the browser, it'll run in these isolates. We start it up in the single Chrome engine, and you can have multiple running in there. They start very, very quickly. So, in 5 milliseconds or something like that is the startup time for these. So what if we just routed all incoming requests to a particular Chrome engine and started a new isolate in response to that, have that service your request, stick around for some length of time in case there's a subsequent request, and then go on from there. And their argument is that that changes the picture. So suddenly, they don't have huge data centers all over the world. The CDNs are smaller than maybe some of the other ones, and they can pack a whole lot into a relatively small footprint and make these things available in a way that they start quickly, they can shut down quickly, they're available everywhere. That's the road they went down. So yeah, this is the picture. When you deploy a worker, that worker within 10 seconds will be live in every single one of those locations. You actually have no choice in the matter. It's not like you're picking, I want to run it in UK East and UK South and Germany or something like that. You just push it up to where it's to its endpoint, and they will distribute it using their CDN, because really they've got this edge network and this CDN, and for them to deploy a JavaScript worker somewhere else just means copying what is in the context of a CDN, a small file, globally, and boom, it's up. So that just seemed like a very attractive and interesting way to put function out on the web to me, and I wanted to do it in F#. So this is where my my lack of Java skills come in. I can barely read this, but really what you're looking at is there's this add event listener API, which is part of the service worker API, and you need to be able to handle that when a request comes in, and you need to then have something that will do it. So essentially you can see the event listener. It says, respond with fetch and apply, calling event request, and then it's going to run this fetch and reply, and you just need to return a promise to a response. And that's hello world, really, in JavaScript. Another very common thing that is done that maybe we don't think about so much is, because they're a CDN, they do things like, this is where I was saying, if the method is a post, we'll just immediately, then we're going to send it off to the edge. Otherwise, we're immediately going to say, well, we were expecting a post. So they, on the edge, you're doing a lot of things like just preventing things from hitting your origin server. This was not something I thought about so much, because my idea is just to make the edge the origin server. Why have two servers if we can just have one? Yeah, some good things about them. Like I said, their cold start times is just not an issue at all. Chrome will start a new isolate very quickly. The latency to where the code is running is not a concern. I think unless you're in, far northern, most of Russia, there didn't seem to be any data centers. But other than that, there seem to be data centers everywhere pretty much, and your functions will be running locally. DevOps is you just post a JS script file to your account, and well, there you go, you've deployed. The cost is pretty low. I don't know how that compares to Azure Functions, but it's 50 cents per million requests. And there's a free tier, which gives you 100,000 requests a day, and the basic paid tier is $5 a month, and that gives you 10 million requests. So it's certainly not expensive. Yeah, and again, for me, this just kind of invokes a simpler time when, before you had to have the last 2 projects I've been involved on, DevOps has been almost a quarter of our budget spend, and there's a lot of effort and weight and things happening to just get even simple things done. And this is just pleases me because it's very, very easy and straightforward. All right, so let's just take a quick look at what the Cloudflare editor looks like. So this is their equivalent of the Azure portal, but it's the Cloudflare portal, and I've basically just gone through from my dashboard to scripts, and then I've got this script for Rec Room IO, which is my domain, and you can see it's running on this route here, so anything, and it's just going to, well, respond with hello world. And they've got a little thing up here so you can test this by, well, that mouse is not working. Anyway, with a refresh, can't see anything, but I suppose I could change something here. Update the preview, and that should, yeah, that was supposed to be an exclamation mark, but anyway, you can see that's that. And you can write any JavaScript you want in there. So then the question becomes, well, what JavaScript do we have to, how do we get Fable to spit out the appropriate JavaScript for that? And in particular, the async, not knowing much about JavaScript, the async was a bit of a mystery to me. But anyway, not to worry, it all worked out. So, yeah. The short answer is it didn't take much, actually. Embarrassingly little when I go to some of the other talks around here to make this happen. You need a little bit of interop. So it's like anything else in the Fable world. You need a little bit of binding or interop code, and then your own code, which can refer to that binding code. Yeah, in the case of service workers, they essentially, there was that event we saw. The slide's not, we'll just go straight to the code, I think. Yeah, so, well, actually, let me back up again. We need to model, we receive a fetch event after registering our handler with a request and a response, and we just need to return a response promise. And that's, we need to get those parts done. And it took me a while, but the key insight for me ultimately is that this new async syntax is really just syntactic sugar for the promises stuff down below, which is good news because if you do promise computation expression in Fable, it basically builds the thing at the bottom. So, job done, really. So, all right, so let's kind of look at Hello World if we were to do that in oops, I keep wanting to use the mouse. All right, Hello World. So, yeah, this part at the top here. So this is the F# to generate that equivalent Hello World worker, a little bit of a fancier Hello World worker, which I do something dynamically, but actually spit out the date time. But the top part here is the interop stuff. The fetch package doesn't actually include the fetch event, so we'll just model the fetch event with the response and the request and the response with promise that's needed. And these two things are, Fable has this very nice mechanism for if you just want to spit out some JavaScript in response to having invoked a function and you don't want to do anything else, but you just know what text lexically you want to go out there and what parameters to provide, you can just do this kind of thing. So what we're saying here is when we, in F#, when we say add event listener with some parameter, basically we just want to emit that code there, which, if you recall from what was happening back in the slide where it was showing how what was actually going on the JavaScript itself, that's exactly all that was happening. And then similarly, we need a way of generating a response. So again, we just say when we create a new response with a string, 2 strings, we're just going to generate a response. And then this part here is the equivalent of those 2 statements that we saw in the JavaScript. So we have the reverse order because we have to define this one before this one. So this is just the add event listener. So this guy here, when that gets invoked, it's just going to spit out the event, that JavaScript there. And similarly, the respond with is then going to just spit out that part there. And then we just have to be able to write the handle request where I'm just saying hello world from the FableConf and get a new response back with a 200 OK. That's So how to make that happen? One of the things I did is I used the Fable REPL, which was really quite an interesting way to do this. So I just went and literally, as you can see, I just pasted that entire set of F# code there and told it to show me what JavaScript code we're supposed to generate. And you see it's pretty much, you can read this, it's almost exactly like the handwritten JavaScript code, in particular this event, add event listener, fetch with a function on the bottom, respond with the handle request, which we've defined up there. And this part here is the promise builder. And that's that. But the problem is we can't paste that into the panel for the, where'd it go? That's on that. We can't paste that in here because it can't have any external references. Those imports, it can't be supported. So we need to bundle this all up. So that didn't take too much. That was just kind of looking at a little bit how Fable is using Webpack and bundling things. And ultimately, going back here, is that the hello world? No, that's this one. Okay. Ultimately, we want to end up with this guy here, which looks pretty ugly. And in order to make that happen, I went and just hacked on somebody's Webpack file. But here you can see this is just a very, very simple Webpack file, which, again, I've almost forgotten how this works, but really it's just using the Fable loader, bundles everything together, and spits out this mimified bit of code. Now the magic in all of this is you can just take that thing, you can copy it, and you can paste it into that panel and have it work. So now if we update the preview, as long as it doesn't make a liar of me, there we go. So, once having gotten that far, everything else is almost just, details really, making the experience nicer and so on and so forth. It's really, once we have those two bits of code, once we have these two things over here, we can then write anything we want in that handler. Where'd it go? Let's scroll down, I think. Yeah. So we can do anything we want in here now. We don't have to just do hello world. So at this point, we can essentially write any code we want and push it up to the edge. So I think it was probably, I don't think I've ever gone into a strange technology where I didn't understand anything about it, just messed about a bit, had it work, generate 20K of weird looking stuff, pasted it in somewhere, and it just worked. I mean, that was like, wow, that's magic. So where do we go from there? So then I thought, well, what can we do that's it's actually going to show this doing something useful? And the idea I had is let's put all this together, refactor a bit, add some tooling for automated deployment, add some connectivity to a database, and build a web API that we can post things, we can do deletes and updates, and so on and so forth. And I think that's pretty much what we need to do there, and kind of we'll look at that next. Okay, yeah. So workers not only let you execute things, they've got this thing called the KV store, which is essentially a key value store, maybe something like Redis or something like that, that's also running locally on all of those edge points. So wherever you are on the edge point, you've got that database available to you. You write something into the database in Canada, it'll appear in the database in the UK within about 10 seconds. So when that worker runs on this side, if it's gone eventually consistent, you're just going to see that data locally there on a local database. So it's kind of distributing the data as well as the code globally. So the key value store. So, yeah. So like I was saying, it's globally distributed, eventually consistent. They say about 10 seconds between when you write something and when it appears everywhere else. They're focused on read performance. You can 100,000 times per second apparently, and that's, I think, I'm not quite sure if that's within one data center or if that's, of course, because you can be running all 200 data centers simultaneously. So, whatever you can do in one location, you can multiply by 200 to get the total global capability in terms of read. Fairly large key sizes, fairly decent value size. Billions of keys, so you don't need to worry about it. I don't say this here, but these keys are also divided by namespace, so you can have about 20 namespaces, so one set of keys for your environment variables. So you could put things like database connection strings and so on there, which of course only your code has access to because no one else has access to the key value store. And another namespace for your data, that kind of thing. They have expiring keys, so if you wanted to do something like generate a URL shortener, you could have the function run, generate the shortened URL, write to the key value store, the original one, do a forward to it. When the key expires, the URL shortened is gone, that kind of thing. Or their use case for this is for authorization. So they're always thinking, how can we protect the origin server, which is a bit different from how I'm thinking about this. I'm thinking about how can we put the origin server on the edge. They're thinking, how can we protect the origin server? So they're saying, well, okay, we want expiring keys so that we can do the authorization on the edge, store the fact that he's been authorized for some point, some duration, and then later on when that key's expired, we'll force him to reauthorize. So I think that's why they added that feature. And they have this nice little thing where you can search for keys by prefix. So you could say, dir1 dot dir2 dot dir3, and then have multiple things below. You can model a bit of a hierarchy by looking for all keys with a given prefix. So it's a little bit better than just a key, so you can do a little bit of querying, if you will. We'll see that later. So yeah, it's kind of the native database for workers. All right, so now I'll just kind of walk through, what time is it? Okay. Walk through the API for how we built this API, or how I did this. Oh, okay, yeah, nope, gotta go. All right. So here's what I came up with the project file for this. So, we split this up a bit. We have a worker file, the web app file, which is a router, contacts, which is an endpoint for storing and fetching contacts, a stats one, web utils, access to the key value store, and the worker interop layer, all split out and organized a bit. Conceptually, it's not really any different, you'll see, from what we saw before. It's just taking it the next step further. So the worker, this file is just that, just that same thing we were looking at before, adding the listener, and then going to the web app and saying route this request with the verb, and we're calling this little path thing, which goes into the request and splits the path splits the path up into a list so that we can actually do a bit of things with it. So once we've done that, route request is where the more interesting things happen. So if we go into the web app, what's happening now is we're getting the route request, and the path is nothing but a list of path elements. And then all we're doing here is, imagine you could bring in the libraries for the combinator-based routing and so on and so forth, but I wanted something that's just very simple. And so really all we're doing here is we're matching on these path elements and doing different things. So, if the path is hello bye, then we're going to do this. If the path is stats, then we're going to do stats. And in the case of contacts, it'll be contacts and slash the rest of the path. Then we'll just take the rest of the list as a subpath and then call route request again in the contacts module, which will then do whatever it needs to do there. I think that's actually still running, so we can have a quick look, because on that panel I just hit preview, so I didn't overwrite what I'd done. So the things I've got are still here, so you can do things okay. So you can see this is, where's that code? Oops, over here. Yeah, okay. You can see the basic get is just going to return home. You can't really, because I need to move this over, but maybe we'll make this smaller. So get just returns home sweet home. So when I hit the get there, that's what happened. Oops. Home sweet home. And then we can go from there. Hello does hello. Whoops, send request. So that's basically doing this one here. The rest of that hello from F#. And then a more interesting one, like this kind of routing. Hello and bye. And then one with an ID. So, if you look over here, the one with the ID is just, rather than matching on a string, it's just matching to a variable, and then you can use that variable to do whatever you want. And so, really pretty straightforward. So, contacts then, which is slightly more interesting. Actually, let's get rid of all this over here for now. And go to contacts. So we define a contact and use the Fable Throth decoder to match that to it. And we have, if you recall, we called on the main router, we then called route request with the same verb and the path, which was the subpath, and then so that's then going through to that contact. So we can then write ourselves a little bit of a contact API there, REST API, if you will. And each of those, oops, I keep wanting to use the mouse. Each of those is really fairly straightforward. So get contacts with a prefix. It's just going in here and going to the key value store, getting it by name, and then returning a new response. And this is just two-stringing the JSON. Getting the contact by ID. Again, you're just going to the key value store and getting that. All pretty much, as you would expect. Putting it, again, you're just getting the text from there, updating it if it's necessary, and so on and so forth. I won't go through these in detail. The repo's at the end. So, but long story short, when it comes down to it, then you can just go here and, for the contacts, you get this specific contact. There's contact 111. We can post a new one. Well, if we originally tried that, it tells us that already exists, so we can just create a different ID and post that one. We can do things like using the prefix matching, so let's find all contacts that start with 1, and we just get back the list of the ones that start with 1, including the one we just created. That's probably enough about that. So how does it perform is one question. So this is just a little bit of something that's going to try find contact 111 100,000 times. And it's basically just going out and hitting that thing. So I'm nervous, it's not coming back. Yeah, there we go, okay. So it'll be done with that fairly soon. So we'll see those stats when that's done. All right. So I don't know, what are they good for? This is where kind of you need imagination, which failed me a little bit. I mean, you can write small APIs, utility functions. I imagine you could probably write things that do server-side HTML rendering and just return the HTML. You could probably do a very good to-do demo with that. I'm just going to wrap up again with a bit more opinion on what you could do with these things, but first let's see if that thing has come back. No, it's still chugging away. No package programming. So one of the things I started thinking about is, one of the first things when I was taking my computer science degree, people started talking about, pointed out the trade-off between space and computation. So you could have a table of results and just look it up in a lookup table, or you could compute the result. And that was presented as a fundamental kind of trade-off. One thing is, now we live in this kind of package world where everything's a package, even the infamous left pad. And you're downloading all these packages and you're integrating them into your ever larger JavaScript application and running that. And what started occurring to me is that there's another trade-off here. And if you look at something like bank account number validation, in order to validate a bank account number, you need to know all of the ways to calculate the check digit, so there's a whole bunch of code you need. But you also need the daily file, which tells you which check digit calculation algorithm applies to which bank. And that file itself might be 500K, so you'd have to download that, and you have to download the code. And you're only going to use this once. You're going to use it when the person makes a payment. So you're going to incur the cost of downloading that, and you're going to incur the cost of those dependencies and the additional complexity, but you're only going to use it once. And you maybe don't care that. Like, sure, it's on the browser, it's already on the browser, it's going to run much faster than if you make a service call. But if your service call is 50 milliseconds, and maybe you just farm all these things out and have like a little community of services that you can run that are written in, well, F# in our case. And yeah, so this is really just what I'd said. You're just using it once. Yeah, so you'd have a worker, just a simple endpoint. You would just post a simple record to it, which, account number, sort code, and you'd get back a record that says, no, the check digit fails, or yes, it's correct, and use that in your payments page. Which then starts you thinking about, well, but. This is kind of scary. Like if I download the code and I've got the package, then I know it's got it working, it's on my thing. But if I call this service, what if the service is not there, if the service is doing the wrong thing, and so on and so forth. But I'd maintain that it's actually not as scary as it sounds, because an infrastructure like Cloudflare, it would not be uncommon that your application is depending on Cloudflare anyway. If you're using the edge to do caching of validation tokens, or if you're using it for various other things for forwarding to other places and that kind of thing, well then if Cloudflare is not running, your application is not running anyway. So if the premise is that they're providing us an ultra reliable way to put some function out there, then maybe we can start using this for all these small utility functions that can just be provided. Someone writes them once and we don't load packages anymore, we just make calls to them. So yeah, I think we kind of need all of that. We need something that's as reliable as the other core infrastructure you're using. And I think this might be, you want it globally consistent, low latency, consistent response times, you don't want any cold start, and it needs to be trusted, at least as much as packages are trusted. And I guess to some degree the packages, yeah. Well, that's just it. I just added this slide today because someone said to me, wow, oh my God, what could go wrong? This is, who knows what's up there in that thing, right? But on the other hand, my comeback would be, but people do seem to trust packages, even though people look at you like a dinosaur if you say, well, no, we shouldn't load all these packages because we don't know what's in that code, right? And you feel very much like an enterprise, kind of a person, because today there's, who knows what packages are there. But one of the ideas had is if you could have an environment like NPM or something like that, where the service that's running, that everybody has shared, is guaranteed to, in the header, have the SHA of the git commit that actually resulted in this thing being pushed up, then when you get those responses and you're worried about it, you actually have some level of trust. Or everybody could just download the repo and run their own services individually. But what NVIDIA has had is if it was an organization that was doing this, and you would just connect to these, and maybe some services would be free, some services that require paid data would be, you'd have to pay for. It's kind of a different model of doing it. Yeah, so these are things, validators, converters, you know, things like image converters. There's just a whole list of things, even something as simple as the list of countries you show in a drop-down. Maybe it would be nice if that list of countries always showed the surrounding 3 countries as the top 3. So, you know, chances are it'd be the most common one to pick, but you don't really want that package. You just go, well, I'll incur the 30 millisecond cost to get that. Yeah, fewer dependencies, less code. Okay, I'm going to see if my, oops. Yeah.
How well are they economically managing the resources they're giving you? For example, do they? Yeah,
I didn't put that on there as, you know, I had all the good things about it. What they do is they give you a certain number of milliseconds of compute time.
Okay, that's supposed to be what I was going
yeah.
It sounds like free compute time.
Yeah, no, it's not free. And what they do is the free tier, I've never run into it yet. 50 milliseconds doesn't sound like much. But, you know, some of those ones where getting all contacts, I don't know if I showed that, but, you know, even when there's 100 of them, it just kind of gets them all. And it was like 100 separate calls to the key value store to get those, and it didn't seem to be a problem. And they say people don't seem to run into these problems. They don't count time when you're doing I/O or time while you're waiting for another service. And they leave your worker running for, you know, once it's up, it'll be up for, you know, a half hour or more. And you can actually store state locally if you want, and the thing can get reasonably large, like, you know, in the megabyte range. I think
it sounds like it's really open for exploitation. If you had a community of different services and they just handed the data off to one another regularly, you could do a gigantic search basically without any one of them ever getting over the time limit.
Well, I mean, that's where the free tier only gives you, what is it, 100,000 requests per day, I think, per day, which is still, I mean, it's free, yeah. And you can't have it on your domain, it's on their domain. So it's, you know, like your name, like we actually got one for Fable, so there's fable.workers.cloudflare.com or something like that. So, you know, we could put a Fable demo up on that one and it would be good for the 100,000. Yeah, so this thing has come back. It's actually much slower than it was. I ran this previously and it was at around 30 milliseconds per request on average. And so I'm a bit disappointed by it. It's the worst result I've ever seen, but still. And you can see the longest one. It's 4 seconds, the longest one. So I don't know where that came from. I've run this up to 10 million. So I've ran 10 million of them with no failures at all. It seemed to be quite good. So anyway, this is the part where I have to admit that the other things that I promised to talk about, I'm not going to be talking about, and I wouldn't have time to talk about them anyway. But the top one is probably the next thing that I would want to look at, is trying to do the same thing for CosmosDB. The problem there is the amount of interop code is larger. I mean, it was almost trivial in this case, but I think it would really, really, really improve the experience of writing something on CosmosDB. The other reason I've been hesitating is the programming model for stored procedures on CosmosDB is still very, very old school JavaScript. There's no promises, there's continuations, and I'm not even quite sure how I would map the Fable to that. And they've just recently revamped the external API to use modern JavaScript practices, so I keep expecting the penny to drop that this will happen on the stored procedure side, and it'll suddenly make the work to have this run as a stored procedure there be much less. And this one here, there's actually a few other people in the room who are kind of interested in that as well, in that the F# mailbox processors today run in process, well, in thread. And so you can't actually exploit the CPU on your machine by starting up a mailbox processor. But if we started a service worker in the browser and had the mailbox process, just had an interface to that, and we would be sending messages to that service worker there, then the mailbox processor would suddenly be a way for actually offloading more and making use of the CPUs on the machine. And you could, in theory, start doing fairly substantial parallel processing within the browser using that service worker and the nice abstraction of the mailbox processor. So that's also quite an interesting thing. Not so much related to running Fable anywhere else, it's still just running there, but these service workers, I think, would lend themselves to that in a nice way if these problems be solved.
Do you see any evidence that they scale as you use it? Are they giving it a lot of few resources?
They are, and you can see that.
So does kick in.
Yeah, you can see that here. Where's my browser? If we go to stats, where's stats? Here we go. That count here, I'm actually maintaining a local variable within that module. And so when we hit this again and again, and that average is nothing, it's just the average over a random number, is just doing this. But if we hit stats again and again, you can see that number bouncing around. So it's staying at 1, then you saw it 2. So every time it's 1, I'm assuming that's a new one. But you keep going and you can see, we've probably got, I don't know, about 6 or 7 running right now. And some of those tests for the length of time it takes to do things, they seem to get better the more load you throw at it. And they say that's true for reading from the key value store. They say the performance of it goes up as you put more load on it. And one interesting thought experiment would be to get some VMs in different places and see how many requests you could actually start doing globally by just trying to hit multiple data centers everywhere else. But
Tunnel from Australia and just send all the requests.
Yeah, it just sends it to a local one. You can't send it to a specific one, which would be nice, because if you could send it to a specific one, then something like is the route to my website up would be trivial to write, because you would just iterate through a loop of 10 different locations and try it all from there, and then just send out a message if it's not there. And it would just, again, it would be basically...
You need the request to come from any place.
Yeah, it has to come from that place. And the other thing they don't have, right now you can only respond to HTTP responses. They don't have any notion of a timer, a heartbeat. If they start having a heartbeat, then you could have queues and have something putting something onto the queue in the key value store and something else reading them off the queue. But if you wanted to have any heartbeat, you would have to have something externally, occasionally hitting an endpoint and triggering that, which, again, that would open up a whole lot of other scenarios that, where you could use this. All right, well, thank you.